Hello, everyone. We are now starting 6.1 again. I will be teaching the full lesson and assigning an assignment afterwards. Happy Monday, and hopefully everybody is feeling rested and feeling good. Okay, so we're going to get started. So this unit is about reaction kinetics, and we'll be defining that in a second. So how do we measure your speed on a journey? So you find your distance traveled and the time it took you to travel from the start to the end, and you do the formula V for velocity equals distance divided by time, which is a physics equation. Or you can use a speedometer that records the speed you are traveling at a specific moment during the journey. This is more similar to how the rate of a chemical reaction is determined, since it is hard to know exactly when a reaction is complete. In chemistry, we measure how fast a reaction happens by observing the appearance of a product, or you can measure the disappearance of a reactant at time points. So this is just a cool quote to put in here. In running, it doesn't matter how fast or slow you are relative to anyone else. You set your own pace and you measure your own progress. You can't lose this race because you're not running against anyone else. You're only running against yourself. And as long as you are running, you are winning. And that's kind of related to what we're going through right now. Throughout this COVID-19, we are in a marathon, and hopefully the marathon doesn't last that long. But for now, you just want to pace yourself. Each day you do a little bit at a time at your own progress, and hopefully we'll get through this. So let's compare how fast propane combusts compared to how fast silver oxidizes. So here you see a silver spoon on the left, tarnishing to this spoon here. So that's the second reaction, silver tarnishing. And the first reaction is showing you methane gas combusting. So what reaction do you think happens faster? The combustion of methane gas or silver tarnishing? So the answer is obviously this one happens faster. This one takes years to happen. So these are both measuring the rate of a chemical reaction. And how do we do that? We measure the amount of product produced over time. So the product right here would be the silver, the tarnished silver over the amount of time. So again, we're going to go over how to measure. You measure the change in concentration of a reactant or the change in the concentration of the product per unit time. How do we do this in a lab setting? You can measure the change in gas volume or the change in color. Let's say your products are a different color than your reactants. You can change the difference in color over time. You can change the difference in mass over time, pH, or electrical conductivity. Reaction kinetics, what is it? It is the study of how fast a reaction happens. It also is the study of factors that affect how fast a reaction happens, and that's 6.2, and how reactions occur. So much of what we know about reaction kinetics is from theoretical knowledge. It is what we think occurs based on empirical knowledge, experimental evidence. So we're going to do a fun activity here, and you are going to comment below the post in the comment box the answer to each of the following questions. There's going to be 4 questions in total. So obviously you're not going to be doing it with a partner, since you are watching this in isolation from home. You are going to write down an answer to each of the following. So out of these chemical reactions, so in your comment box, if you could just write your name and then your answer to each question, number 1, number 2, number 3, number 4. So out of these chemical reactions, boiling of food, rusting of steel, curing of concrete, setting of dental fillings, how do you know a chemical reaction is taking place? Okay, so if you want to pause the video at any point, you can, and write down your thoughts. What is happening in a chemical reaction on the atomic level? So you can just do like a couple sentences here. You can do point form as well. And using your list from number 1, place your reactions in order from slowest to fastest. Okay, so which reaction of these do you think is happening the slowest to the fastest? And finally, why is knowing the reaction rate important? So think in terms of industry, pharmaceuticals, etc. Okay, so you can pause the video and write down your thoughts there, and then you can go to Google Classroom and post your comments after this post. Okay, so some more chemical reactions to think about. Ozone formation and depletion. So I don't know if you guys saw in the news that because everybody's being isolated to their homes, the amount of ozone has depleted over time. So the rate of ozone forming has depleted because of the fact that people aren't going anywhere and nothing is really happening, which I guess is a plus. Mineral formation, metabolism is a big one. Metabolism, every time you eat food and you're creating ATP and energy, that's a big chemical reaction there. So if your metabolism is really high, that means you're digesting your food really fast, and you are releasing energy really fast. Industrial chemists produce materials in reasonable time with little waste. That's the goal, obviously. Okay, so again, we're gonna keep defining rate of reaction in this lesson. It's kind of a conceptual lesson with a little bit of math at the end with graphing. So rate of reaction is determined by measuring the rate of formation of a product or the rate of disappearance of a reactant. So make sure you understand that definition. So for example, when water breaks down into hydrogen and oxygen, you can measure the disappearance of water over time or the appearance of H2 over time or O2 over time. Remember that during a chemical reaction, bonds between atoms are broken and reformed. So this takes time, and the time required will vary depending on the reactants and their bonds. So some formula that you should know and understand. Reaction rate is the quantity of product formed over the time. So in other words, the change in quantity of your product or your reactant over the change in time, and change is indicated by this delta symbol here or the triangle symbol. Okay, so what does quantity mean exactly? So it could be the change in volume, the change in mass, the change in temperature, the change in pressure, the change in color absorbance, pH, or conductivity. So if you look at this reaction here, calcium carbonate, which is a solid, if you react it with hydrochloric acid, it forms carbon dioxide gas, water, and calcium chloride. The total mass of the vessel decreases when the carbon dioxide gas that's produced is allowed to escape. So basically, as the time of this reaction keeps going, the mass is obviously decreasing because the gas is escaping. So here it shows you this reaction happening, calcium carbonate with hydrochloric acid, and in this case, the gas is being held in here. But anyways, the mass is decreasing over time, and you can measure that using this graph, and you can measure the rate of the reaction here. And we'll talk about that in a second, how to measure the rate of the reaction using this graph. Another way to measure the rate of the reaction is using change in pH. So for example here, the reactants are SO3 and H2O, and you're forming H2SO4. So H2SO4 is a lot more acidic than the reactants. So you would expect the pH to drop as the time goes on. Okay, so let's do an example here of a type of question you'd be tested on. A reaction uses up 15.0 grams of HCl within 10 minutes. What is the average rate of reaction? So remember, we want to watch for sig figs. You want to make your units always per unit of time, whatever they give you in the question. And the units, again, are determined by the information given. If the reactant is disappearing, then the rate will be negative. So this is a really important point. Okay, if the product is appearing, the rate is going to be positive. So in this case, we're measuring the rate of a reactant disappearing. So we're going to put a negative, and we're going to put the rate of disappearance is 15.0 grams divided by the time, which is 10 minutes. So 15 divided by 10 is 1.5, and you put the units grams per minute. And for the sake of, we're going to pretend that there's a little decimal here behind the 10. to make this accurate sig figs is 2 sig figs. Okay, example number 2. The reaction of aluminum and hydrochloric acid produces 490 milliliters of hydrogen gas in 56 seconds. What is the rate of the reaction? So again, you just take how much hydrogen gas is being produced, so you know product is being produced, so it's positive, and we're dividing it by the amount of time that's gone by. So the answer is 8.75 milliliters per second. So let's see if this is the correct number of sig figs. So in this case, there are 2 sig figs here and 2 sig figs here. So you would actually have to make this 8.8 milliliters per second. So if you could just correct that to 8.8 milliliters per second. Okay, so stoichiometric rate relationships. So basically we're looking at mole ratios in our balanced chemical equation. So in this case, NO2 is disappearing to form NO and O2. The rate of disappearance of NO2 is exactly equal to the rate of appearance of NO. Why? Because it's a 2-to-2 ratio. Okay. Whereas oxygen is appearing at half the rate as NO2 is disappearing because it's a 2-to-1 ratio. Okay, so that's what this is showing here. Okay, so it says consider the reaction Fe2O3 plus 2Al forms Al2O3 plus 2Fe if 17.80 grams of Fe is produced in 12.0 seconds. What is the rate of production of Fe in moles per second? So what we have to do first is we have to calculate the number of moles of Fe. So they gave us the mass. The mass is 17.80 grams. So you take that. So here we go. Here's the first step. The mass is 17.80 grams, and you divide it by the molar mass of Fe, which is 55.85, and you get 0.3187 moles. Okay. And then to do the rate, you want to divide that mole by the number of seconds that's gone by. So 12 seconds have gone by. So we divide through 0.3187 divided by 12, and you get 0.0266 moles per second. And then for part B, they say, what is the rate of consumption of aluminum in moles per second? So we look at the balanced equation, and we notice that Fe was in the product side, so that is positive because it's appearing. But aluminum over here is disappearing, so it would be negative, right? And the ratio of aluminum to iron is 2-to-2, so it's exactly the same number. Okay, it's just going to be negative because aluminum is disappearing, whereas iron is appearing. So the answer to B is the same number, but it's in the negative. Okay, and the mole ratio is 1-to-1. If it wasn't 1-to-1 ratio, we'd have to set up a mole ratio, which is going to be example number 4. So just a side note here, as you're listening to this lesson, it's really important to write down the solution separately as I'm talking, and just writing it down because I think it consolidates better as you're writing down the answer. Okay, example number 4. For the chemical reaction represented by this equation, if the rate of disappearance of N2O5 is this number, moles per liter times second, at 60 seconds, determine the rate of appearance of oxygen at the same point. So they gave us a value for N2O5, for the rate of that disappearance, and they asked us for what is the rate of appearance of oxygen at that same point. So what we're going to do is we're going to set up a ratio. So you have to watch the second video that I'm posting in order to, because I'm going to walk through the document camera examples on that video. Okay, so we're just going to keep going for now, and then you're going to play the video to fill in your example number 4 after. Okay, so there's a typo there. This is example number 5. This is also going to be taken up on the second video through a separate video. Okay. Okay, so now we're going to talk about graphs, determining average rate of reaction using graphical data. So you can find the slope of the secant going through the 2 points on the curve to find your reaction rate. So if you wanted to find the reaction rate between a certain time and another like second time, you just draw a straight line between those 2 points and you take the slope, which is y2 minus y1 divided by x2 minus x1. Okay, so maybe you can practice this question. Obviously, we can't do it with a partner, but you can practice this on your own and see if you understand how to calculate the slope of a line connected. So let's see here, page 352. So I believe this question was in the practice quiz. And I took it up on our Zoom meeting, but I will take up any questions again in other Zoom meetings coming up this week. Okay, so instantaneous rate of reaction. You can also use the graph to determine the rate of the reaction at any single instant in time, a value known as instantaneous reaction rate. How do you do that? You draw a tangent. So what's a tangent mean? It's a straight line that touches the curve at one point and does not cross through the curve. Okay, and then you just find the slope of that tangent line using the slope formula. Okay, so here we go. Let's say they asked you to find the reaction rate at time t. So you go up to the graph and you put a red dot here at that time t, and then you draw a straight line, which is shown in blue, through that point, but it doesn't cross the curve at any other point. Okay, and that is called the tangent. And we're going to take the slope of that blue line, and that will be our reaction rate at that time t. Okay, so here's another example. Let's say they asked us to find the reaction rate at 3 seconds of this reaction. So what you do is you put a point at 3 and you draw a straight line, okay? And the slope of this black line will tell you the instantaneous speed at 3 seconds. So we picked 2 points on this black line. The first point we picked was 0, 1.5, right here, shown right here. Okay, and the second point we picked was 5, 20. Okay, so y2 minus y1 is 20 minus 0 divided by x2 minus x1, so 5 subtract 1.5. Okay, and you get this answer here. Okay, so here's another example using a chemical reaction. So if H2 and I2 combine to form HI, and we were measuring the rate of the concentration of HI appearing over time, and let's say we had some sophisticated equipment to graph it immediately, you would see something like this, where HI is appearing at a steady exponential rate over time, and H2 is disappearing, this green line right here, at a steady rate over time. Okay, so using H2, let's go to this green curve. The instantaneous rate at 50 seconds. So I go to 50 here, and I go up, and I put a point here, and I draw a straight line through that point. That's the tangent. And I'm going to take the slope of that line. So the rise over the run, which is negative 0.28 divided by 40 seconds, and I get 0.0070 moles per liter per second. Okay, if we wanted to find the instantaneous rate at 50 seconds for HI, so I go to 50 and I go up to HI and I draw a tangent and then I find the rise over run of that line. It would be 0.56 divided by 40. Okay, and you get 0.0070 moles per liter per second. Okay. Okay, so I do want you to practice the graphing. It's really, really important to know how to do that because that will be on your first assessment this week for this unit. Okay, so that's it for this video, and please watch the second video for examples 4 and 5, and I'll also be going over practice question number 1 on page 352. Thank you.